Yes.
That's not true.
Yeah,
The anode is the more negative number. So a lot of times, but not always, you are subtracting the negative, which is just adding, obviously. For the net ionic, two things. Sometimes you're not going to be given that picture, so you could just kind of like figure it out. Sometimes you're going to have to come up with it on your own. So remember, it's a redox reaction. One side is being reduced. That means the number is going down. So stop. The big number going down, 2 to 0, that's being reduced. That means the other one's being oxidized. The number is going up, 0 to 2 plus, in order to get that net ionic. It's important for us to get our brains thinking today about this, because the lesson today is going to involve these electrons that have already been canceled. So we are going to have to know something that's not there. We will only be given this net ionic, and from there we need to know how many electrons there were, which for this one's pretty easy, but sometimes you know how we had to multiply 1 by 2 and 1 by 3 to get it to cancel. It's just an extra layer of thinking. Okay, so we are going to start today by making a charty chart. I vote tall wave because we're only doing 4 columns. So on your, can you get out the white sheet of paper, please? That's because I forgot to stop hitting record for an hour, and I recorded like a half hour afterwards.
You could have just cut it.
Very classic.
No, she said hot dog.
Oh my god. I think you should do a tall ways because it's only 4 columns. Hard for tall ways, okay? I am going to write in red and green as well. I would do red for equations, green for conversion factors.
Yo, Bam, and you want to dish me one of them?
Why did you grab it? I never actually. That was so accurate.
I wasn't expecting it.
Yeah, you know.
Am I gonna fail my test?
We're going to finish it tomorrow, so you have a chance to look up on this one. All right, if delta G is positive, we know that that is non-spontaneous. On the AP exam, they will say it's not thermodynamically favored. Okay, I just was looking through some practice rounds for us to do off the College Board website, and it says thermodynamically favored. So just to remind you, if it's non-spontaneous, that means K is less than 1. The equilibrium lies to the left. Look at all these reactants. Nothing happened because it's not spontaneous. If this happens now, I have to look over there because I taught this wrong all day. E cell is going to be negative. And I know why, I just can't think that fast for some reason. Let's tell you on time. Okay? I'll tell you in a second. If delta G is negative, that's going to be spontaneous. Look at all the stuff I made. I didn't have to do anything. So K is going to be greater than 1. That means it lies right. Look at all of these products. Also, remember that doesn't mean rate. It's not kinetics. It doesn't tell us how fast. Dinosaur poop turns into diamonds. K is like to the times 10 to the 47, but it's not fast. E cell is going to be positive. We have 3 different delta G equations. The first one we learned was delta H minus T delta F. That is for when you have enthalpy and you have entropy. Okay? We're going to learn 2 more equations just for solving for G. So when you see a question that says solve for G, you're going to need to choose from these 3, but it's like physics where you just pick the one where you have the units for. We also learned negative Ratlin. Yep. So that is when you are either solving for K or you have K. And today we're going to do negative 9. N capital F E. Okay? The N is the invisible electrons that are not going to be there that you have to think back to. So it's the number of moles of electrons. So when we were practicing balance equations, one of the steps is the electrons had to cancel, and then they were crisscross gone forever. So now we have to go back to uncrisscrossing, not gone forever, and figure out what that is. That number is going to be F. F is called Faraday's constant, 96,485 coulombs, which is a capital C, coulombs. A coulomb, I wrote this down, is a joule times a volt. And that matters because our units are always like, are they joules or are they kilojoules? Okay? A coulomb is an amp times a second. We are just going to do that to solve for time tomorrow, but let's get it all on the sheet today. Okay? None of this stuff is something you have to remember. It's all on your equation sheet that you were given on the AP exam. You just have to pick it up. All right. If we have to solve for K, then we got to use Rattling. Yep. We already learned one of the equations for E cell. That's going to be our cathode minus our anode. But we could also use, oops, that's supposed to be E. We could also use -9. The E part of it is E cell. Okay? So that on occasion we will have to use to solve for E cell. We are going to start at sample problem 10, but leave your warm-up out because we need that for one thing, and leave your equation math out too. Okay? Look for sample problem 10. You need to get a basket.
Then he can't do his work at home for that.
You can keep it over by. All right, we need EVO first. So if you don't have EVO, come grab it and you actually need it. Do you have an EVO? Can you get it out, please? Can you make sure I turn around and get your email out?
You guys have your English on?
Oh, that?
Oh, during our class it was that point.
Okay. Part of this unit maybe seeming to be hard is it's intimidating. So if we look at number 10, it says use appendix E to calculate E cell. But then we look at that and there's like lots of letters, lots of charges of things. So similar to when we see a polyatomic that maybe we're unfamiliar with. I'm like, it doesn't matter what it is, make it X. This is going to be a really similar thing. This whole unit is going to be filled with really intimidating redox equations. It was 13 steps to balance them. So we ended up with lots of stuff. That's what we're looking at now. It's lots of stuff. To get used to it and kind of desensitize to the craziness, number 10 and 11, what I'm asking you to do is just do cathode minus anode. So all you're doing is finding it on EMU to make yourself feel better. It's just a number. Do your cathode minus anode. It will help you recognize where all of those things come from because it should match just about exactly in here. So do 10 and 11 with your battle buddy. Ready? All right, number 12. Use, if you didn't finish that, you'll get a chance to do it again. Use the standard reduction potentials in appendix EMU to calculate the standard free energy change delta G. We have 3 options for calculating delta G. So in your brain, you look at the 3. Do I have a delta H and delta S? No, so I'm not going to use that. Can I use Rattling Bob? No, I don't have K. So I'm left with -9. So it says to calculate delta G and then calculate K. So I'm down to this for -9. The N part is the invisible electrons that are not here. They were in the 2 up here that I crisscrossed and canceled forever. So let me tell you how I think about it. Likely you'll have a different way to think about it, probably even a better way to think about it. But I would look at this and be like, there's a bunch of 4s. I bet it's 4. Because I must have multiplied this by 4 to get my electrons to cancel. I'm also going to look at this and say, okay, well, this is a +1 charge. That means it lost 1 electron. And I had to do it 4 times to get it to cancel. So I'm pretty sure it's 4. If I really wanted to check, I would do EMU. So look at your EMU and look at silver, the very, very first one, AG, alphabetical order. It says, yeah, the 0.7991. But it says 1 electron. And I don't have 1 silver, I have 4 silver, so I must have had 4 electrons that got crisscrossed. I just multiplied this whole thing by 4. So my N is going to be 4. My E is going to be my cathode minus my anode. So if you couldn't match your letters last time, match your letters now. And then after that, you need to solve for K. Our only equation we have for K is Ratelingbob. So you're going to do delta G equals negative Ratling to solve for K. Okay? Ready, set, and go.
You don't have R though.
Fancy R, 8.3145.
8 point what?
3145.
8.1?
Oh, what, my God, look at the poster.
8.135.
Nope. Okay, let's look at 13. More letters for you to not get freaked out. This is desensitization. At first you're like, oh my God, I can't find anything. But now at least you found a couple things. So this time maybe you'll find them all. What you're doing is this time you are given delta G and you need to calculate E. So the only delta G equation I can use is -9. But this time I have that 87,000 because I need to be in joules. You have to figure out what the invisible electrons were. Now this one is a little bit trickier. It's not as obvious. What do you think the invisible electrons were? We're solving for E this time.
How come you don't use the OH negative?
She solved it or not? Yeah, she solved it.
She solved it like 6 times. Just kept doing it.
Okay, remember Q versus K. The very last thing I want to teach you today is a Q versus K concept. There is a math equation called the Nernst Equation that is actually easier to do than this, but the College Board has decided that you're not smart enough to do that math, so you have to explain it this way.
So rude.
I know, that's what I say. If Q is greater than K, remember it has to go left, right? It goes to the reverse reaction. If Q is less than K, it has to go right, so we have to do a forward reaction. All right? The forward reaction in a voltaic cell produces electricity. Focus on makes I'm not going to bother you with that because I know we're talking right now. The forward reaction in a voltaic cell is spontaneous. It's spontaneously producing electricity. The reverse reaction, if I switch these two around, is non-spontaneous. It would not occur. It would reduce the electricity. I'm not producing electricity anymore. Okay? So the reason I had you keep your warm-up out is because it says look at the voltaic cell depicted below, and it's not there, but it's the same one that's on your warm-up. So what we need off of that is this. We need just the net ionic.
I lost my warm-up.
You need it for tomorrow too. Can you not actually put that? I think this was just the answer to A that you have written down. That's all you need. What it's asking, would the EMF, so that is another way to say electricity, the E cell, would it increase, decrease, or stay the same if I increased my copper 2+? Okay? This is how you have to explain it to get your point. K is going to be products over reactants, pure solids, pure liquids do not go in. I'm going to pretend that their concentration is 1 over 1, just to make a point, which is very similar to the point you have to make. If I change my conditions now, that's called Q. I'm not in equilibrium. If I increase my copper, I'm going to pretend it increased to 10. My Q now is going to be less than my K. 1/10 is smaller than 1. If Q is less than K, I have a forward reaction. In a voltaic cell, the forward reaction produces electricity. So if I just took another scoop of the zinc, it should increase our electricity. The forward reaction increases electricity. Okay? Please do B with your battle buddy. Ready, go.
Can we just do that?
Nope. You have to explain that Q is greater than K, so reverse reaction reduces. Like, you have to say all those 3 points to get your point. Just your chapter 20 worksheet number 3 through 5.